Welcome to clickmeproject.com. Let me discuss about the process depth estimation of face images using the nonlinear least square model. Let me see about the process depth estimation of face images using the nonlinear least square model. Multiple face images and fingerprint images from different subjects were collected. The face images in different poses and illumination variations and background changes are trained by extracting the feature values from all the images. In this paper, they have constructed the 3D images from the retrieved 2D images. As a modification and enhancement, we have done this process as a biometric authentication system. The test face images, here we are also using fingerprint images so that it will be well enhanced like a multimodal biometric system. So we are also using the fingerprint images. Test face images and the fingerprint images were first pre-processed using Gaussian filter to remove the noises from the image. Then shift features were extracted from the face images. Miniature features were extracted from the fingerprint images. The fingerprint image feature values and the face feature values were combined. The images were well trained and the test images were compared with all the trained images. If the face images and the fingerprint images is of the same person, then the person is authenticated and the process ends. Else if the person is not authenticated, means the process ends here. If the person is authenticated means, then we go to the retrieval step. So the face images which is similar in the to the corresponding face images that we have given as an input is retrieved from the database. For this, we are using equivalent distance measure to measure the minimum distance between the test feature values and the trained image feature values. Let me see the flow of the process depth estimation of face images in nonlinear least square. Initially, the face images were taken and they were pre-processed using Gaussian filter. In pre-processing, Gaussian filter is used to remove the noises from the input test image. It is often desirable to perform some kind of noise reduction on the image. Gaussian filter is a nonlinear digital filtering technique often used to remove the noise. Such noise reduction is a typical pre-processing step to improve the results of the later processing. Gaussian filter can be applied in the image by first designing the Gaussian filter and then applying it to the image using infilter function. Then from the pre-processed face image, shift features were extracted. Shift is an algorithm which is used in computer vision to detect and describe the local features in the image. For any object in the image, interesting points on the object can be extracted to provide the feature descriptor of the object. This description extracted from the training image can be then used to identify the objects when attempting to locate the object in the test image containing many other objects. To perform reliable recognition, it is important that the features extracted from the training images can be detectable even under changes in the image scale, noise and illumination. Such points usually lie on high contrast regions of the images such as object edges. Another important characteristic of the features is that the relative positions between them in the original scene should not change from one image to another. Plus, maximum is calculated for the scale space. Then the key points were localized. The nearby point system interpolated. The low contrast key points and the edge responses were eliminated. Then we go to the fingerprint image. The initial fingerprint images were collected and then it is repressed using the same Gaussian filter. Then miniature features were extracted from the fingerprint image. From the binary thinned image, miniatures were extracted by 3x3 pattern masks. This process seems to be simple. It is necessary to consider the elimination of the fast detected miniature. So the next, the extracted shift features and the miniature features were combined to form the test image feature. Then the test image feature is compared with the trained features, and if the test image feature is already present in the trained image feature means then the person is authenticated, else the person is not authenticated. If we give the same person's face image and fingerprint image only, the process will be authenticated, otherwise it will be not authenticated. Then if the person is authenticated means then the face is recognized from the database. So for that we are using equivalent distance measure. So the face image that has the minimum equivalent distance with the corresponding face image that we have given is retrieved and it is displayed. Let me see the execution of the process depth estimation of face images using nonlinear least square model. In this paper, if you want to run the code, select the file main.m which is located in the source code folder. Right click it and you will get run file. You will get the user interface which is required in order to run the code. Here first when you click the run button, you will get this window. When you click the face button, select any of the face images given in the database. If then give the corresponding fingerprint image of the person which is given in the dataset. Then when you click on authentication, if the person and the fingerprint were the same, then the person is authenticated. Then the same person's image is retrieved from the database. If you want to, if we give wrong person and the wrong fingerprint, then the process provides the authentication is not provided, and also the retrieval is also not provided. If we give correct face and the fingerprint images, means this will work. And if we give any other face images which is present other than the database, for example this image, this is not a trained database, the features will be extracted for the image, but this person's image is not trained by us. So if we give this person's image, when you click authentication, then the process will close and the message box will be displayed. So you cannot give any other than, you cannot give any images which are not trained in the database. Hence we are providing an authentication system which combines both face images and fingerprint images, and for face image feature extraction we are using shift, and for fingerprint face extraction we are using miniature extraction algorithm, and the process works like that. Thank you.